You see the essential parts of any C program. In this video, we will learn one more sorting technique, and that technique is named as insertion sort. So first we see what is an insertion sort. How does this work? So we see all these things separately. Thereafter, I will write the code. Now see the mechanism of insertion sort. Here randomly I take few data you see on the screen. These are few elements. You see few data. I am reading this 23, 34, 12, 45, 33, 67, 7 and 11. So you can assume this, you can assume these numbers as elements of an array of size 8, because on the screen there are 8 numbers. Now you also see that these numbers are not in a sorted form, that is, the numbers are not either in ascending order or in descending order. So we have to sort these numbers. Sort means we have to make it either in ascending order or in descending order. In this video, we will make these numbers in ascending order. And now I start to tell about the insertion sort. Here you see the array of 8 elements, and in insertion sort we make a sub array. Sub array means already you see an array of 8 elements. Inside this array we make a small array, and after each complete process we add one more element to that sub array. In this way sub array increases, and at the end of the program the sub array becomes equal to this array you see on the screen. Now I am going to start. For the first time we take a sub array containing only one element, and you see in the beginning, at the beginning 23 is that number, and you also know that any array containing only one element is already sorted. So this element is sorted, 23 is sorted, so I am going to make it green. This means that this is okay. Okay, I have done. So inside this whole array, the entire array, there is an array, there is a sub array of only one element, that is sorted. And at the same time, we will learn the mechanism of this program as well. So you see, now we go to add one more element to this subarray. Subarray is of only one element. Now I am going to make it the subarray of size 2. So I have to add 34 in that array. So at the same time we will learn the mechanism also, and we first mention here the index number. This 0 is the index number for 23. So to make it different from the numbers above, I am going to color it with different, and suppose it is red, and 34 is at the second place, so its index number will be 1, and you see 12 is at the third place, so its index number will be 2. Similarly, here we have to type 3, thereafter 4, 5, 6, and the index of the last element, that is of 11, will be 7. Okay. Now, as I said earlier, that now we have to increase the size of subarray. So we take the next element, that is 34. I have to add that. Here let us learn the mechanism also. Here we take I for the first element, and we start I am marking these I and J with some other color because these two stands for the variable. So I am marking these two with blue, and also to this J. Okay. So J in the program, in the code, J will always start from the index 1, and for every J will run. For the first time J will be 1, you see, with J the index is 1, you see this in red, and for the next time J will be 2, so J will be here above 12 for the next time. But for each J, whether J be 1, 2, 3 etc, I will be initially 0. In the intermediate step, I may take other values, but initially for each J I will start from 0. I will show you this thing. So the work is, I have already a sub array of size 1 in hand here. Now I have to make the sub array of size 2. For that I include 34 to 23. Now you can see these two make a sub array of size 2, and you know, if array name is A, then 23 will be stored under AI and 34 will be stored under AJ. Now we compare AI and AJ. If AJ is greater, then we increase the value of I by 1. Obviously here AJ is 34 and AI is 23. Obviously AJ is greater, so I will be increased by 1 and I comes 8J. So I type J and I at the same place. Why did I write at the same place? Because I am trying to make you understand the mechanism as well, not only the insertion sort but also the mechanism. So I has been increased by 1, so it has gone to the second index number, that is 1, and thereafter if AJ is smaller, but here that is not the case, because I have already told you that AJ is greater, 34 is greater than 23. So for J equals to 1, corresponding to J equals to 1, our work is complete. So this time now we got the array size of 2. We have now array size of order 2. So I am going to make 34 green. Okay, you see we have sub array of size 2. You see this sub array 23 and 34. These two are sorted. Now J, the value, now we increase the size of this sub array. For that I already told you that for each next step we keep the value of I 0. So I will be here again, I will be 0. You see I is above 0, and we have done the work for J equals to 1. So now this J will go above the 12, above 12. Now we repeat the same thing again. Now I is 0, we compare AI and AJ. If AJ is greater than AI is 23, AJ is now 12, but you observe that AJ is not greater than AI. So what we do? First, this 12 is stored. I am going to show you here AJ is stored, and you see that AJ is 12 this time. Now I have stored, and this AJ is named as key. This is the key. And thereafter we I displace the numbers. Displace means I keep this 34 to 12. I keep 34 at the place of 12 and this 23 at the place of 34. So here will be 34 now, and here will be 23, and key, key is containing 12, so that 12 comes at the first place. Now we have done the work corresponding to this j equals to 2. J is 2. We have done the work, so I am going to make it green because our work is complete corresponding to j equals to 2. So this time you see that we have a subarray of size 3. In this way we increase the size. Now we work for j equals to 3. So this time we keep the j above 45. We have already a subarray of size 3. Now we are going to make this subarray of size 4. For that, as I said earlier, I is kept 0 for each j, and here you see the I is already at 0. It has index number 0 as you see here. I am going to rub it, clear it, because this was for the previous step. Now AI, if A is the array name, so AI is compared with AJ. It is observed that whether AJ is greater than I. Yes, it is greater because 45 is greater than 12. So the value of I will be increased. The I then will be above 23. Again it is compared, and it is observed that still AJ is greater than AI. Obviously it is greater because 45 is greater than 23. So the value of I is again increased. Now I will be above 34 and its value will be 2. Here you can see the value is 2. Now again the value of AJ and the value of AI is seen, and it is observed that whether AJ is still greater than AI. Yes, still greater than AJ because 45 is greater than 34. So this I now comes at the place of J. The value of both J and I becomes equal. The values become equal, both 3. Now there is no difference between I and j, so there will be no swapping. There will be no swapping. In the previous case, we have swapped, we have interchanged the places of 12, 23 and 34 to get the sorted subarray. But this time we do not do the same thing because I and j both have come at the same place. Both have taken the value of 3. You know, ij stand for the index number, so there is no need to go to run a loop, whether it be a for loop or a while loop, because there is no difference between I and j. So corresponding to j equals to 3, our work is complete. So 45 will be included in the sub array. Now I am going to make it green. Now our sub array, the size of sub array has been increased. The sub array is of size 4, you see, and this sub array is sorted. Now the time comes for the time comes to work for j, the next value of j. So here j is 3. Now the value of this j will be 4. So that j must be written above 33. Here the value of j is 4. And as I said earlier that for any j, the value of I must be 0. Initial value of I must be 0. So I will be typed here. Now it is time to insert 33 in the sub array, which you see in green color. Now again ai is compared with aj. I is 0 because for each j initial value of I is kept 0. Now ai is compared with aj. It is seen that whether aj is greater than ai. Yes, it is greater than ai because aj is 33 and ai is 12. So if it is the case, then the value of I is increased. So the I comes above 23. Again it is observed that still in this situation, whether aj is greater than ai, obviously aj is greater than ai because you see aj is 33 and ai is 23. So the value of I is again increased. So I now comes above 34. You see, from I equals to 0, I has been now 2, and this work is done. I will make the code, and in that code you see the sliding of I has gone from 0 to 2. This will be done in the code with the help of while loop. Now again ai and aj both are compared, whether aj is greater than ai. This time aj is not greater than ai because aj is 33 and ai is 34. So now it comes to interchange the value. So first, to interchange the values, first we store aj under the variable key, and you see aj is 33. After doing this step, we clear this. I have cleared 33 because I have already stored 33 under the key, under the word key, under the variable key I have stored. So I have deleted 33 from this place, because if you consider the array of size 5 containing 33 at the end, then that sub array is not sorted. And thereafter 45, this 45 is written 8 under j, and this 34, you see this 34 is written above the index number 3. Actually we displace the last two here, the last two integers by one step. We make these two elements one step ahead in the right side, and here you see now there is a vacant space, and that space is under ai. So we give this key to ai. So here will be 33. We have given 33 to ai because 33 has been typed below ai. So ai takes the data stored under key, under the variable, under this variable key. Now for j equals to 4, our work is complete. So I am going to make this 45 green. Okay, now our sub array has increased in size. Now this sub array is of size 5. Now we do the work for the next value of j. Here the value of j is 4. The next value will be obviously 5 here. So accordingly I typed this time j above 5, the index number 5. This third row, the row in red, is for the indices, and you know whenever you go to work for the next value of j, initial value of I, you have to keep initial value of I 0. So for each j, initially I will be above the index 0. Now we repeat the same process again. We observe whether aj is greater than ai. Obviously it is, because aj is 67 and ai is 12. So obviously 67 is greater than 12. So the value of ai, the value of I will be increased. It will be 1 now. And again we do the same. Now ai is 23, aj is 67. This time as well aj is greater than ai. Again we increase the value of ai. Now so ai will come above 2. I will come above 2. Again we do the same. We compare. Here again you see aj means 67, that is greater than ai 33. So this time as well the value of I will be increased. So the I goes above 3, the index number 3. The value of I is now 3. Again we see, observe the same, whether aj is greater than ai. Yes, it is. So the value of I will be increased. Now it will be 4. You see I is above 4. Now again we compare aj and ai, whether aj is greater than ai. Obviously it is greater because 67 is greater than 45. So I comes at the place of j, as I and j both has come, both has taken the same value, so there is no need to interchange the numbers. It is okay. So since this is okay, so I make this value 67 in green. Now you see our subarray, this subarray is sorted and has increased in size. Now it is of size 6. We do the same. Similar way we proceed. We keep going until we reach at the end. Now we take the next value of j, and the next value of j will be 6. So I typed j this time above 6. Now you know, for each j we have to keep initial value of I 0. So I type I above 0, above index number 0. Now we do the same thing. aj, it is observed that whether aj is greater than ai. You see on the screen aj is 7, ai is 12. This time aj is not greater than ai. So before proceeding ahead, I am going to rub it because it was for it stands for previous steps, not the present step. So I erased the lower typed things. Now you see aj is not greater than ai. aj is 7, ai is 12. So we cannot increase the value of I. I will stand at its place. Now we do we slide this whole thing one unit right. You see, I will slide these whole things, means 12, 23, 33, 34, 45, 67, one unit to the right. For that I have to clear 7. But before clearing, we have to store this value 7 as before under the name key, under the variable key, and that is age, and its value is 7. As I have written in the lower row, so I can now erase this one, and this whole thing will slide one unit to the right. Okay, you can see, you can compare the previous one with this present. So this whole thing has been shifted one unit to the right. This is done using a for loop. I will write type an inner for loop to perform this shifting. And now shifting has been done, and now the time comes to place this 7. So this key will be stored under AI. You see, under AI the place is vacant, so here we will store that key. So AI will be equals to key. In the program you will see, after inner for loop I will type AI equals to key. So now you can observe that our sub array is complete. This is already a sorted array. So corresponding to 6, corresponding to j equals to 6, our work is complete. So now the j will take the value 7. Here will be 7. So, and as I have taken the next value of j, that is 7. So as I said initially, I must be 0, and you see that I is already at 0, because you see I is above 0. Here is the I, so it is okay. And before performing the last step, we clear this thing, because this relates to the previous step. Now we repeat the same process. It is observed that whether aj is greater than ai. Yes, it is. You see, aj means 11. 11 is obviously greater than 7. So the value of I will be increased. I will be above 1. I will be 1. The value of I has been increased. So you have to keep in mind, when do we increase the value of I? We do this when aj is greater than ai. Remember this. Now we again observe that this time, whether aj is greater than ai, Not, it is not. You see, AJ is 11, AI is 12, so AJ is not greater than AI. So now the value of I will not be increased. What we will do? We store this value. Whenever this case happens, then after that we store this value, the value AJ, and we store this under the variable key, and this is obviously AJ and its value is 7. Now, sorry, its value is 11. Now, after storing the value, we erase this. I have erased, and thereafter the sub array is shifted one unit to the right. You see, I have shifted one unit to the right. Okay, I have shifted one unit to the right. Okay, there is something wrong. I am showing you the previous step again. Okay, this is the case. Okay, I shift not the whole subarray. I shift the numbers between I and j. You see I here is the j. So we shift the numbers between I and j. You see AI is 12, I is below I, you see 12. So we shift not the whole subarray but only the array, only the numbers between I and j. So I shift this whole thing. Okay, shifting is complete. I shifted the numbers which were between I and j. These numbers have been shifted one unit to the right. Now you see a vacant space below I, and this vacant space stands for AI, and in all the processes AI were given the value of key. So here will be AI equals to key. In the code I will type this thing, AI equals to key after the shifting, and in the code for this shifting I will use inner for loop. So the vacant space will take the key, that is AI will be equal to key. So here will be 11. Okay, now our entire, now the sub array is of maximum size. So our work is complete. You see the marked line is sorted. First you see cell 7, thereafter 11, 12, 23, 33, 34, 45, 67. So in insertion sort, we take a sub array of size 1, thereafter we add one element in each step. In doing so, the size of sub array increases, and at the end its size becomes equal to the initial size of the array. So now we go to write the code. I show you. Here you see the essential parts of any C program. Thereafter I paste something. Okay, this is not working. So I type manually. Here I type int I n for the size of the array, and I is for the index number. And you saw in the mechanism that I have taken j as well, so here will be j. Now we show the user a message, enter the size, so that he can enter for the size, enter the size. And to scan the size we use a scanf function. So here will be %d because size is always in integer, and thereafter %n because any value is stored at an address. Thereafter, as soon as we got the size, we can declare the array. Suppose its name is a, so this will be an. Now we take the elements for this array. For that we again show a message to the user to enter for the size. Okay, to scan the elements we use for loop because the elements are with indices, with index number, so we use for loop to scan the data for the array elements. And index starts from 0, it goes up to n minus 1. So here I type I less than n, and after each run I will be increased by 1 because indices are at a distance 1 0 1 2 3 etc. And here will be a scanf function again to scan the data for the elements. As I have declared integer data, so the elements will be integers %ai. Okay, it is okay. Now we have taken the data for array elements. Now the time comes to sort. So we take again for loop, and in the mechanism, as I have shown you at the beginning, before writing this code, I have shown you that j starts from 1 and j goes to the last index, that is n minus 1. So I typed j less than n, and after each completing work for each j, the value of j will be increased. J will go to the next element, and thereafter inside this we type inside this okay, I type inside this for loop, and before and for each j I have shown you that the initial value of I will be 0. Okay, and you also saw that if aj was greater than ai, then we increase the value of I, we shift I, we increase the value of I by 1. For that we use the while loop, and inside this we type the condition, and same condition aj is greater than. When do we slide When do we increase the value of I? When aj is greater than ai. Then we increase the value of I. For that, I typed here I plus plus, and thereafter the case may be the other case. There may be other case. Here aj is greater than ai. There may be a different case, and for that I use if. There may be a case that aj is less than or equal to ai. Then for that we use we whenever you saw in the beginning in the mechanism that in that case if aj is less than or equal to ai, we shift the numbers between I and j one unit to the right. For that we use for loop. For that shifting we use the for loop. And before shifting, you also saw that before shifting the value of aj is stored under the variable key. Since I have used a variable key, so here I have to declare it first. So I have declared. Now after that we run an inner for loop for the shifting. I had shifted the numbers between I and j one unit to the right. For that I take this inner for loop, and this inner for loop runs from k equals to j. Again I have taken this k a different variable, so I have to declare it, and here I type k. So k starts from j because in shifting the first data comes at the place of j, and this is done up to I plus 1. So here will be k greater than I. This ensures that the minimum value of I is I plus 1. And after each and for each data I had shifted the numbers in a group, but you have to consider it as shifting of single data from the end. You have to assume that one data at a time, one data is shifted to the right, and you have to take that data from the end. So it will be j, thereafter j minus 1, thereafter j minus 2, and so on. It will go up to I plus 1. I show you. You can see, if you revise the mechanism, then you can observe that the data shifted towards right, their in their indices from the end is j, thereafter j minus 1, and it goes up to I plus 1. So here accordingly k is greater than I. This means that k will be at least I plus 1. and to go from j to I plus 1, you have to move backward. So k will be increased by 1 after each run. So k will be so the third statement will be k minus minus. And for shifting, to shift the data in the backward direction, here I type ak and here a k minus 1. This means that at the place of ak, the data stored in ak minus 1 will come. So this ensures forward shifting, that is shifting towards right. And you also observe that when our shifting got completed, after that we give the value of key to the AI. So AI will keep the value of key. Okay, now it seems that our code is complete. Now the last part is to show the sorted to show the sorted array to the user. For that we use printf function. First we create a new line. For that I have used here \n, and we can also type a message inside this message. The sorted array is and here we use \n to create an additional new line. Thereafter we use a for loop to to show the elements to the user. For that I paste here, but I have to modify this because I have to show. So here will be printf and here will be AI, not %AI, because we have to show, we are not going to scan, we have to show that. For that there is no need to type %. Now I am going to show you the entire program. You can see this is the upper half of the program and this is the lower half of this program. Now I am going to run it. Okay, it is asking for the size. Okay, I take an array of size 10. Now it asks the data for the elements. So I randomly take 12 numbers, 10 numbers. First 12, 34, 9, 0. You can take any 10 integers. 45, 44, 9, 4, 78, 57, and you see here the number is continuous. The numbers are not at a distance, so it is showing a it is here you look ambiguous output. So to get a clear output, here I type \t. Using \t we get the elements, sorted array elements at a tab distance. Here I take an array of size 12, and so I have to take 12 numbers. Okay, you can see there are 12 numbers: 45, 55, 90, 33, 9, 8, 7, 33, 67, 23, 0 and 111. You see the numbers are in increasing order: 0, thereafter 7, 8, 9, 23, 33. 33 is 2 times. Obviously you see 2 times 33 is 2 times 1, and second 33 is here. So after 33, 45, 55, 67, 90, 111. Okay, so our elements are sorted, so it is okay.